So today I am going to discuss about the transverse section of Dracaenaceae. It is a little bit difficult in case of monocot stem, dicot stem, monocot root, dicot root. So without getting late, I'm going to enter to the content. The young stem of Dracaena is a typical monocot stem. It is a typical monocot stem. It is different in a feature that, although it is a monocot stem, it contains melistamatic zone which acts as the cambium. Normally, the vascular bundle of monocot stem are conjoint, collateral, and closed type. Let me explain that conjoint vascular bundle means both the xylem and phloem are on the same bundle. Next one is the collateral vascular bundle, which means that phloem lies towards the periphery and xylem lies towards the center, and it may be open or closed type. As we have known that in monocot stem it is closed type because of absence of cambium, which is in case of normal monocot stem. Thus, they lack secondary growth in thickness and vascular system be completely composed of primary tissue in case of normal monocot stem. The vascular bundle remains irregularly scattered in the ground tissue. As you can see in the figure there that the ground tissue has irregularly scattered vascular bundle, forming an attacked stele. It is a type of stele. Stele means simply the composition of pericycle and vascular bundle. Some monocot belonging to family Liliaceae, as like Dracaena, Yucca, Agave, aloe vera, and others, exhibit a special type of secondary increase in thickness, which is different than the normal monocot stem. The tiers of Dracaena stem is almost circular in outline, which shows following internal structures from outside the ring. First one is the peritoneum. Peritoneum is composed of cork or phylum, that is cork cambium, which is also known as phyllogen, and secondary cortex, which is also known as phylloderm. I'm again repeating, it is composed of cork or phylum, that is cork cambium, phyllogen, and secondary cortex, which is also known as phylloderm. The comparison of both is known as peritoneum. It is nicely discussed in secondary growth. The cells of phylum are of rectangular, thickly suberized and dead. As it is dead, it helps in mechanical support of the tissue. The phyllogen is 1 or 2 layer thick, thin-walled and tangentially elongated. It is tangentially elongated. Second is cortex. It is undifferentiated region which is composed of parenchymatous cells and it contains starch grains. It contains starch grains. You can see in the picture. Third one is the melistamatic tissue. The cortical cells outside the vascular bundle form several layers of melistamatic zone, and the cells of this zone are almost rectangular and generally radial, which acts as a cambium. As I have already said, it is different in this point in comparison to the normal monocot stem. Fourth one is the vascular tissue system. The primary vascular bundles are freely scattered in the ground tissue, which are large in size, typically conjoint, collateral, and closed type. Secondary vascular bundles are present near the periphery, which are smaller in size, you can see in the figure, and remain embedded in the thin wall tissue. The secondary vascular bundle are concentric and amphivessel type. Amphivessel means that phloem is surrounded by xylem. Secondary phloem is composed of short sheep tube elements, while secondary xylem is composed of tracheids and xylem parenchyma. This is the point to remember. Again, I am going to repeat. Secondary phloem is composed of short sheep tube elements, while secondary xylem is composed of tracheids and xylem parenchyma. Third one is the ground tissue. The tissue extends from the inner side of meristem zone and fill up the major part of stem. You can see in the figure that it has filled the major part of stem. The cells of young tissue are thin-walled, parenchymatous. Parenchymatous means it is thin, transparent, with intercellular space. As I have told you that in case of monocot stem, it lacks secondary growth in normal case, but in Dracaena, it lacks secondary growth. But in Dracaena, as I have told that the meristematic zone acts as the cambium at a very late stage of development, a wide zone of secondary meristem. That is, cambium develops outside the vascular bundle in the parenchymatous region. I have shown you in the figure that cambium is outside the vascular bundle. This meristematic zone coats of vascular tissue on its inner side. It coats of vascular tissue on its inner side, and the vascular tissue are arranged in concentric manner and amphivasal in nature. Amphivasal means phloem is surrounded by xylem, and the amount of parenchymatous ground tissue also increases, and therefore the diameter of the stem also increases. In this way, it is completed. I hope you have known about the transverse section of Dracaena. So, thank you for watching. If you have any problem in any kind of topic, in any subject, botany, zoology, etc., you can just ask me in the comment box and I will make it available.